see that that's the difference of two perfect squares, so we're going to factor. So we're going to get x squared minus 9 and x squared plus 9. And we set that equal to 0. All right, now we see on the left here, we still can break that down further. So we're going to break that down to x plus 3. And then we'll also get x minus 3. Now, x squared plus 9 is not the difference of two perfect squares. It's the sum of two perfect squares. So we are just going to bring that down because that's not factorable. All right, then from here, what we're going to do is we're going to take each term. We're going to do our little t-chart, and we're going to set them equal to 0. So we're going to take x plus 3, set that equal to 0, subtract 3 from both sides, and we'll get x equals negative 3. So there is one solution. We're going to do the same thing with the next one, x minus 3, set that equal to 0. In this case, we'll add 3, and we will get x equals positive 3. There's another solution. All right, now, when we get to this one, because it's not factorable, we're going to do the same thing. We're going to set it equal to 0. When we set that equal to 0, we're going to bring the 9 over and make it negative 9, or subtract 9. And we will get x squared equals 9. Now, when we do this, just be careful that we're going to be taking the square root of both sides. And remember that when we take the square root, we need a plus or minus. There. So let's just be a little careful with that. All right, and the square root of x squared is just x equals, don't forget the plus or minus. Oops, made a mistake. This should be a negative 9 in the square root there. Sorry, I know that looks a little weird, but that should be a negative 9. Let me just take this and rewrite that over here so you can see it a little bit better. So that's going to be plus or minus the square root of negative 9. There we go. All right, now, remember, whenever you have a negative underneath the square root, that's an I. So basically, you just take the square root of the 9, which would be 3, and because there's a negative attached with it, I. So our two solutions here would be x equals 3i and x equals negative 3i. So all together, we have 4 solutions. X equals 3, x equals negative 3, x equals 3i, and x equals negative 3i. For a function v of x that can be used to find the volume of the box. So if you look at the picture on the right here, you'll see that those little squares that are x's are cut out. So these spaces in here, here, and here are cut out. And then if you look at the picture to the left, you'll see that's kind of what I have left. So if you're looking right here, that's what it will look like three-dimensionally speaking. Okay, so the height of the box will be x, and then each of the sides, the bases of the three-dimensional shape will be 6 minus 2x and 4 minus 2x. So if we want to get an equation for v of x, remember to find volume, it's length times width times height, or area of the base times the height. I don't know what it was that you learned, but so the area of the base would be the 6 minus 2x times the 4 minus 2x. And then the height of the whole thing would be x. I'm going to throw that in front. So there's an equation for the volume. So again then, for part A, to find or to represent the volume of the box, what we would do is we would use this equation right here. Okay. Now, in part B, what they want us to do is they want us to determine the restricted domain. Now, remember that domain stands for all of your x values. So what I did was, if you see over here on the right, now you should see I have my calculator there, and I just put the v of x equation that I got in part A into my y1, and I did a zoom 6 And then all I did was I changed my window. So my x min was -2 and my x max was 6. So that it just looked a little bit bigger. So what I want you to notice is on your x-axis here, those represent obviously x values, that would be your domain, but they also represent, in terms of the equation, we need to think of the sides of our box. Okay, so if we look here, we see that the graph hits the origin. So that would be 0, 0. Well, let's think about this. I can't really have any values that would be to the left, or 0 for that matter, because that doesn't make sense for our problem. We can't have negative lengths. So in that case, we know that x can't be 0 or less. So in other words, for part B then, what we would want to say is we do know that x has to be greater than 0. Okay, so let's just think about that. So now I have to look at the other end of my graph here. So I see here that I'm hitting at x equals 2. That would be right down here. That's x equals 2. And then over here, my graph is hitting at x equals 3. All right, well, what I can do is I can look at any of those values. Let's say I look at v of 2, and I'm going based upon the part A equation. So let's say I put in 2. So then I would get 2 for x, right? And then I would get 6 minus 2 times 2, which is really 6 minus 4, right? Okay, but then here's the problem. I'm going to get 4 minus 2 times 2. And that's an issue, because what is 4 minus 2 times 2? That's 0. So, and I can't have the length of any three-dimensional figure, or really the length of anything, be a 0. So that 2 does not make sense for our domain. I could do the same thing if I plugged in any number bigger than 2. Let's say I plugged in 3. So again, I'm plugging it into the part A equation. So I would get 3 times 6 minus 2 times 3. And then I would get 4 minus 2 times 3. Well, I have two problems here, because in the first set of parentheses, that would give me 0. And again, I can't have the length of a side be 0. And here, in the second set of parentheses, I'm getting a negative number, and I certainly can't have that for the length of any side. So therefore, we have to look at the fact that if the x value is 2 or higher, that's not going to work for this problem either. So essentially then our domain has to be bigger than 0 but less than 2. So in between 0 and 2, but not including the 0 and the 2. And that would be our answer for part B. For the last part, part C, they want you to determine to the nearest hundredth of a cubic inch the maximum volume possible under these conditions. So if you look, I have my graph, and I just did second calc max, and I went to the left, I hit enter. I went to the right, I hit enter twice. And if we look at the maximum volume, we would be looking for the y value. So that would be this value right here. Okay, so our maximum volume, because volume is the y value in our v of x equation from part A, we would then look at this, and we would say, now they said it had to be to the nearest hundredth, so that would be 8.45, and it is volume, so it's going to be cubic inches. Inches cubed. All right, so this question is asking us to find A, B, and C. I kind of did a little setting up for you. So remember the three original equations that we are given, we label them A, B, and C, like you see up at the top of the screen in white. So then what I did was, I just set this up ahead of time, was we're going to split these off. So what we want to try to do is look at the three original equations that are in white, and we want to see what would be the easiest variable to get rid of, whether it be the A's, the B's, or the C's. And I think the B's are the easiest to get rid of because they all have the same number in front of them. They all have a 1. And yet, if you look at equation C, that b is negative, so that'll be pretty easy to get rid of. So if you look at what I wrote in green, I grouped equation A with equation C, and then follow off to the right of the screen, my second step, I grouped equation B with equation C. All right, so let's look at the A and the C, my first step there. So if I add those equations, I'm going to get an A here. My B's will cancel out, which is what I want. Then I'm going to get plus 5C equals 16. Now, second step, I'm going to repeat the same process, again trying to cancel out the B's, and I'm going to add my B and my C equations. So I'm going to get 3A. My B's are going to cancel out. I'm going to get plus 3C, and that equals 12. All right, so now we have two new equations. Remember, we label them D and we label them E. So the next step that we want to do is to take those D and E equations, and we want to try to eliminate yet another variable. So I'm going to write those equations down. Now, I want to try to eliminate a variable. If I look at them, I can see that probably the easiest thing to get rid of would be the A's, and all I would do with my D equation is to multiply that. And let's see, why don't we multiply this entire equation by a -3, because that will cancel out my A's. So that's going to give me -3A minus 15C equals -48. And then I'm going to just leave my E equation alone because my A's will cancel out if I do that. So let me bring my E equation along, and that equals 12. All right. So now all I'm going to do is I'm going to add my two equations together. The A's will cancel out. That's going to be -12C equals -36. And when I divide out my -12, you can see that I will have C is equal to 3. And there's my first variable solved. Next is going to be to pick either your D equation or your E equation. I chose my D equation right here. And I'm going to plug in my C equals 3. So A plus, now I'm doing my C is 3, so 5 times 3 would be 15, equals 16. And then bring that 15 over, and you'll see that A is equal to 1. All right, so we're almost done now. Our very final step is going to be to find, there we go, to find the variable B. So go back to the very original, the 3 white equations at the top of the screen. Pick any one that you want. I'm going to pick B because it looks easy. And then I'm going to write A plus B plus C equals 6. And I'm going to solve. So I know A is 1, B, that's what I'm trying to solve for, and C is 3 equals 6. So I've got B plus 4 equals 6, and I'm sorry, this is going to get squeezed in, but I wanted it all on one screen. Then your B will be 2. So we have A is equal to 1, B is equal to 2, and C is equal to 3. In 36, they give you the equation, and they tell you that T sub A stands for the room temperature. If you read the question, it's the second sentence, second line down on the left-hand side. It says the room temperature at McDonald's is 70 degrees Fahrenheit. Now, if we look at Part A is asking us to, let's see what it says. It says, according to this model, in other words, this equation, what is the temperature of the coffee when it is initially poured from the coffee pot at T equals 0? So you're going to plug in T equals 0. So I'm going to do T of 0 equals 110 e to the negative 0.019 times 0 plus, and then the ambient temperature, which is the room temperature, which is 70 degrees. All right, so we have T sub 0 equals, we get 110 e, anything times 0 is obviously 0, so that would just be e to the 0 power, and hopefully you remember anything to the 0 power is 1. So this just becomes 110 times 1 plus 70, and that would be our T sub 0. So then T sub 0 is going to be 180 degrees Fahrenheit. There we go. All right, now part B is asking you how long, which is time, in minutes to the nearest tenth of a minute, will it take for the coffee to cool to the serving temperature of 155 degrees. So the serving temperature would be the T of T, the temperature of the coffee after a certain amount of time, and that's the time that we're trying to figure out. So we're still going to use that equation that we have up at the top of the screen, but instead of writing T of T, we're going to write 155, because that's the temperature that we wanted to get to. And then what we're going to be solving for is little t. So negative 0.019 times little t. And again, that ambient temperature, or the surrounding temperature, room temperature, is 70. All right, so if we look at this, we want to try to get little t by itself. So I'm going to start by subtracting 70 from both sides. When I do that, I get 85. So 85 equals 110. Oops, make that look like 110. e to the negative 0.019 times t. All right, so now I need to get rid of the 110. So I'm going to divide both sides by 110. Okay, now you can do the decimal equivalent of 85 over 110, but I'm just going to leave that as 85 over 110 is equal to e to the negative 0.019 t. Now if you remember, whenever we have an e and we are trying to drop its exponent down, we ln both sides. So I'm going to ln the left side and I'm going to ln the right side, and that will cancel out that e. Okay, so let's just bring that up over here. So I have the ln of 85 over 110, and I'm just going to leave that. It would be more accurate. Equals negative 0.019t. All right, so now we almost have t by itself, so all we need to do is divide both sides by negative 0.019. Cross that out, and that will give us what t is. So carefully put that into your calculator. You do the ln in parentheses, 85 divided by 110, close your parentheses, then hit divide by, negative 0.019. And you're going to get 13.56995. And then it says to the nearest tenth of a minute, so our time is going to be 13.6 minutes. And that's the time it will take to get that temperature of that coffee to be 155 degrees Fahrenheit. So if you read the question above part A, it's talking about tsunamis and all of that. And if you look specifically at the second paragraph there, it says a tsunami is observed from a coastal pier where the normal depth of water is 10 feet. So you can see by my graph here that I wrote the equation of the midline, which would be y equals 10 feet. And we should probably say that our y-axis is measured in feet. All right. Then if we look across our x-axis, that's going to be t. And let me make that a little bit darker. Maybe we could see that a little bit better. And that would be t, and that would be measured in minutes. Okay, and this again is feet up there. Sorry. All right, so it says to graph one full cycle of the wave with the time in minutes on the x-axis and the water height in feet on the y-axis. Now, if you do read the first paragraph, it does say the water level in a tsunami will initially fall below its normal level, then rise an equivalent distance above the normal level, and then finally returning back to its normal level. So that being the case, what we want to do is, this is its normal level right here at 0. It would be at a height of 10 feet. And then it falls below its normal level. Okay, and if we read that second paragraph, the second sentence, it says, following the cycle pattern described above, the tsunami has an amplitude, a height, of 20 feet above the normal water depth. So what happens is its highest point will be 20 feet above this blue dot, and then its lowest point will be 20 feet below that blue dot. Okay? The other thing it says is the depth of the water will vary sinusoidally with time. If you read the last sentence in the first paragraph, it also says assume the period of this cycle to be 18 minutes. So in other words, if we have a sine curve from the beginning to the end should be 18 minutes. Now remember, a sine curve, I'm just going to draw a little picture here. If we're going to go down first, because it does say that the water level initially falls below its normal level, so that means it will go down first and then up. This distance right here, or this time, should be 18 minutes. So right here in the middle then should be at 9. So I'm going to put a dot at 9. Now remember a sine curve, if it goes down first, we want to read again, it says that the amplitude is 20 feet. So if I'm already at 10 and I'm going to go down 20 feet, I should be at negative 10. Halfway in between, and halfway in between 0 and 9 is 4.5. So 4.5, I'm just going to put a little x there, there's 4.5, and I'm going to go down to negative 10. So there would be my dot. So the first part will look like that. Okay, oops, let's pretend like that hit at negative 10. Okay, now I should then be doing the opposite, which is going up 20 feet, and I'm already at 10 feet. That's my midline right here. My midline is at 10. So what I'm going to do is I'm going to go up 20 feet from there, which would put me at 30 feet high. And again, since I have a start, is it here at 9? Okay. I'm going to do that in green so you can see it. And I finish at 18, then I want what's the middle between 9 and 18. And the middle between 9 and 18 is going to be 13.5. So I'm going to go to 13.5, and I'm going to follow that all the way up to 30, which will put me right there. There we go, right? That's 13.5, 30. And then there's the remainder of my curve. Okay, so part A says graph one full cycle of the wave with time in minutes on the x-axis and the water height in feet on the y-axis. All right, so we did that. All right, now let's look at part B. Part B says to write a sine function, so we want to write an equation. So if we look at part B, let's just write that. So it says f of x is equal to A, remember that stands for amplitude, sine B, x, remember B stands for the frequency, plus D, and that's your vertical shift. All right, so f of x is equal to, well, our amplitude is our distance from the midline up to our maximum, or the midline down to our minimum, so our amplitude is 20. Now, because my graph is going down first, though, even though my amplitude is 20, remember we need to show what direction it's going in first, so that's going to be a negative 20. sine. All right, now b is your frequency. And remember, with the way that we can find that b, I'm just going to write it over here, is to do 2 pi, well, that's supposed to be an equal sign, sorry about that, over the period. And period means how long it takes to complete one full curve. Well, it takes 18 minutes to complete one full curve, so that would be 2 pi over 18. And if I reduce that, that's going to be pi over 9. So that's my b. So I have pi over 9 erg x. Okay, let me throw that in parentheses. And then my vertical shift, which would be plus 10. So plus 10. So there is the equation, and let's make that look like a 1 so you can really see that. Part D is asking, part C is asking you to predict the depth of the water 12 minutes after the tsunami first reaches the pier. So minutes is an x value. So basically what they want you to do is take our answer to part B, and they want you to put in 12 for your x value. So what we're doing is we're doing f of 12. So that's going to be negative 20 times the sine of pi over 9. There we go. Let's plug in 12 for our x value, and then plus 10. All right. So really at this point, what you're going to do is plug this into your calculator. Just be a little bit careful when you're doing that. So you're going to do 12 times pi, divide that by 9. You can take the sine of that answer, multiply it by negative 20, and then add your 10. And you should end up with 27 point, that's a decimal, 32050. And it does say to the nearest tenth of a foot, so we're going to say 27.3 feet. Part D is asking what will be the minimum depth of the water during this cycle, and when will it occur? If you look at the graph, you can see at time 4.5 minutes, the graph goes down to a minimum. So that's what it's looking for, the lowest point on the graph. And that lowest point is at negative 10. Okay, so do you see at 4.5 minutes, your height per se, sorry about that messiness, is a negative 10. Now that negative 10, basically what that means is that you are 10 feet below your normal water level. Okay, so 10 feet below normal water level. Okay, and again, that's going to occur at time equals 4.5. Now, part E is asking you to explain, well, what will be seen by observers when the cycle does reach its minimum depth. Okay, well, since the normal water level is 10 feet, and we are going 10 feet below that, then what's going to happen is we're not going to have any water. Okay, so basically for part E, what you can say is since the normal water level is 10 feet, okay, so normal water level is 10 feet. If you go 10 feet below that, that should be an equal sign, I'm sorry, then you're going to have no water left. Okay, so normal water level is equal to 10 feet. So if you go 10 feet below your normal water level, there is 0 feet. I'm just going to put the units there, 0 feet of water left.